Hey there, Explorer! The following program was brought to you by Team Neutrino in association with the Ames Public Library. Team Neutrino is a FIRST Robotics team based out of Story County. We've been helping students build awesome robots for over 10 years. FIRST Robotics offers exciting robotics opportunities for students of all ages, from pre-K all the way through grade 12. Many local elementary schools in Story County offer FIRST Lego League, a program which teaches robotics basics. Lego League is a great way to get involved with robotics and a fantastic STEM activity we hope you participate in this school year. You might even have some fun building Lego robots along the way. Ask a trusted adult or teacher to help you join a team today at www.firstinspires.org. That's www.firstinspires.org. But for now, sit back, relax, grab some popcorn, and enjoy the show.
Hello and welcome to Full Steam Ahead with Team Neutrino. My name is Claudia and I'm a senior robotics student with Team Neutrino. Over our next few weeks together, we'll be exploring fun and engaging science, technology, engineering, art, and math opportunities that you can enjoy right here in Story County. Each episode of our show will highlight unique science fields, explore local opportunities anyone can enjoy, and provide you with fun activities you can do from home. In this episode of Full Steam Ahead, we'll be exploring the field of robotics and how you can create your very own moon rover with household items. We're here at the Biorenewables Complex on the Iowa State University campus to see what we can learn. Let's take a look inside. The Iowa State Biorenewables Complex is home to the Department of Agriculture and Biosystems Engineering facilities at Iowa State. Here, students learn about mechanical engineering as well as biosystems engineering, a special branch of engineering where students use what they know about engineering to solve problems in their environment. Things like how machines work outdoors or how food is produced. Team Neutrino, on the other hand, uses the Biorenewables Complex to compete in the FIRST Robotics Competition. From the beginning of our season in January through our competitions in April, Neutrino uses the facilities here at Iowa State College of Engineering to plan, design, and build our robot. Each year, Team Neutrino's robot is designed to compete in a different challenge. I'm here with Felix. Felix is Team Neutrino's 2021 robot, which won first place at the Greater Kansas City Regional, a competition where FRC teams like Neutrino compete. But before we explore how robots like Felix work, we need to explore the basic parts of a robot. There are several important parts of a robot. A robot consists of a frame, a way to move, like wheels or treads, limbs or mechanisms to accomplish tasks, a battery to provide the robot with electricity, wires to connect all the parts of the robot together, and code to tell the robot what to do. Without these parts, a robot wouldn't be complete. Our robot may seem complex at first, but when you break it down, it's just a lot of simple parts working together. This year, our robot was designed to pick up and shoot 7-inch dodgeballs into a target similar to this one. Our robot does this by picking dodgeballs off the floor using a roller, funneling them into what we call a turret here at the top, and throwing them at the target. Our robot moves using a set of wheels connected to electric motors, which make the wheels rotate. All of this is fueled by a powerful battery, which carries its electrical current to the limbs of the robot using these wires. Building a robot is a complicated process from planning it to assembling it. The robot knows how to shoot the ball because we tell it what to do. To accurately shoot dodgeballs at the target, we needed to make something that could work without human help. That means we can't drive it with a controller. To do this, the robot uses things called sensors to know where to aim. Sensors are just like your eyes. They tell the robot's brain what is going on in the real world so it can choose how to react. The brain uses code that we've written to take the information from its sensors and use it to shoot the ball. This code is simply a set of instructions that tell the robot what to do in a language it understands. Using this code, we can make our robot incredibly accurate. Let's watch Felix in action. Now that we've learned about how Team Neutrino's robot works, let's use these same science concepts to design moon rovers with Cardinal Space Mining, another fantastic robotics program. Welcome to a segment we're calling Stay-at-Home STEAM Activities. We're here at Cardinal Space Mining's workshop here at Iowa State. Cardinal Space Mining is a robotics club which designs a rover each year for NASA's robotic mining competition. This club does everything from in-depth teaching to community outreach. I'm here to share with you fun and exciting science, technology, engineering, art, and math activities and experiments that you can try safely in your very own home. Before we get to our activity, Ethan Bosch, the captain of Cardinal Space Mining, will be showing us around the workshop.
So, as you can see, we're in the Student Innovation Center at Iowa State. So, this whole space here, we've got all the competition teams. There's Solar Car, SAE, all of that, and then of course we've got our own space right here that you can see. There you can actually see our robot that's in progress right now. So we've got the drivetrain segment there, we've got some of the frame, the hopper, we've got some of the power boxes and the batteries that we use to power our robot over there. Just LiPo batteries, that kind of thing. And then over here you can see our Mars 2 robot, Marineris. And so we brought this one to competition a few years ago. And we've kind of kept some of the overall design philosophy with the robot. This trencher here that you can see, this bucket ladder. But one of the big things that we've been challenged in the past several years is to really shrink this robot down. So, you can see just how big this drivetrain system is here versus the one behind you right there. It's a huge compaction of the robot, and that's one of the big challenges we have. And, since we design and build a robot every year, we need lots of people, all different majors, all sorts of different experiences to help us build the robot, help us program it, machine parts, all that kind of stuff. We're looking forward to some pretty big things in this coming year, and it'll be great to get a ton of new people on board and see what we can accomplish. Now we're standing in the control room for our lunar test chamber. So as you can see in there, we have our regolith simulant, which is what we use to simulate the surface of the moon or Mars. So you can kind of make it out, but you can see that every footprint in there, it gets really stuck in there. So this stuff, it flows really loosely, but when you compact it, it gets, it really compacts down, gets really tight. I guess in comparison for texture, it's kind of like baby powder, almost. But so what we have to do is there's 30 centimeters of that really fine stuff, and then at the bottom of this testing chamber there's gravel, which simulates icy regolith, which is what we expect to find up there on the moon, and that contains water ice, which is going to be very important for future missions, because it's water, so you can drink it, you can split it into hydrogen and oxygen, and now you have air to breathe and you have rocket fuel. So that's kind of the overarching purpose of the competition, is to learn more about mining those kinds of materials. And so, we're very fortunate among a lot of competition teams that we actually have our own chamber here to simulate the mining. So, we bring the robot in, just do a couple mining runs, and then see how much regolith we can pull out of the ground.
Today I'm also joined by Moriah and Connor. Moriah is another member of Cardinal Space Mining who will be showing us today's fun robotics activity. The following stay-at-home STEAM activity is provided us by NASA, the space agency which runs Cardinal Space Mining's competition. You can print off more information about this free classroom activity right now at nasa.gov. But for now, go ahead and find a trusted adult and let's get started.
For today's activity, we will need a ruler, rubber bands, hard ground candies with a hole in the middle, 2 5-inch square pieces of corrugated cardboard, 1 6-inch piece square of cardboard, tape, scissors, 2 plastic drinking straws, and 1 sharpened round pencil. The first thing that we're going to do is make the body. So pick up your 6-inch piece of cardboard and we're going to make 2 folds along the corrugation. The corrugation is the lines that run along the cardboard, so make sure when you fold it is with the line and not against the line. The next thing you're going to do is poke holes in the body for the pencil to be the axle. The next thing we are going to do is make the wheels. So we get your 2 pieces of 5-inch cardboard and we are going to draw diagonal lines to find the center and poke a hole in the center. Next, we are going to attach the wheels to the body. Make sure that your wheels are taped securely to your pencil. Now we are going to use the straw and the hard candies to construct the rear wheel. Next thing we are going to do is attach the rubber bands to the rover. Now that we have our rover, let's go outside and try it.
Did you know? The first ever industrial robot was named Unimate, short for Universal Automation. Unimate was used to make cars faster and more precisely than people could. Since then, robotics has become an important part of everyday life. Everything from toys to Roombas make life easier and more fun. You don't need to be on a robotics team to explore the awesome robots around you. How many robots can you spot in the Story County community?
Welcome back to Full Steam Ahead with Team Neutrino, brought to you in partnership with the Ames Public Library. My name is Claudia, and I'm here at the Ames Public Library to showcase the incredibly fun science, technology, engineering, art, and math books you can find here. Today we'll be looking at one of my personal favorites. If You Love Robots, You Could Be by Mai Nakamura is a wonderful look at some of the awesome careers that involve robotics, engineering, and coding. This storybook explores everything from electrical engineering to the scientific method with fun, real-world examples. You can find If You Love Robots, You Could Be today, right here at the Ames Public Library, along with thousands of other educational titles and fun weekly events you and your whole family can enjoy. Now, back to the show. Before the break, for our stay-at-home STEAM activity, we created a self-powered moon lander from household materials. Let's jump right back into it and see how the rubber band rover can drive on its own. Twisting the pencil counterclockwise will wrap the rubber band around the axle. When you're ready, let it go and watch your rover speed forward. If your car isn't rolling, try making the wheels smaller and rounding the corners. This works because when the rubber band is twisted around the axle, it stores up energy. This stored energy, known as potential energy, needs to escape somehow. The potential energy escapes when you let go of the rover. The reason the rover moves when it's released is because the potential energy is converted into motion energy, known as kinetic energy. This kinetic energy is what spins the wheels and causes the rover to move forward. If you enjoyed this stay-at-home STEAM activity, you can find more simple and engaging tutorials online. Visit www.youtube.com/teamneutrino for nearly 2 hours of free stay-at-home STEAM lessons. From do-it-yourself elephant's toothpaste to our incredible Rube Goldberg machine, you're bound to find something fun you can do. So what are you waiting for?
See you there!
Did you know? In 2020, NASA launched a new Mars rover named Perseverance into space as part of a mission to explore possible life on Mars and to learn more about one of our neighboring planets in the solar system. It's incredibly cold on Mars, around -80 degrees Fahrenheit, and dust storms make it hard to navigate. Despite the challenges, Perseverance will live on Mars for one full Mars year, which is about 687 Earth days. Would you have what it takes to live on Mars?
Thank you for joining us for this episode of Full Steam Ahead with Team Neutrino. Today, we learned about robotics principles from engineering to basics of code. We explored the Iowa State Biorenewables Complex and learned how to make our very own moon rover with Cardinal Space Mining. Next week, join us as we explore plant life in our local community and learn about photosynthesis firsthand. See you there.
Thank you for watching Full Steam Ahead with Team Neutrino. We hope our show inspires you to continue to innovate and design while enjoying the fantastic and fun opportunities Story County has to offer. See you next time!